Welcome back. In this video, we will prove the second trigonometry identity we seen in the previous video, which is sin square theta plus cos square theta equivalent to 1. To prove this one, we need a right angle triangle. So we have a right angle triangle. Let me denote this angle as theta, and this is 90 degree. And let me name the vertices. So let's say this is A, B, C, right? The side AB is opposite to theta, right? So opposite is AB, and adjacent is AC, and hypotenuse is BC. In order to prove this second identity and one of the important trigonometric identities, I'm going to use Pythagoras theorem. So what is Pythagoras theorem says? Square of hypotenuse BC squared equal to square of other two sides. So AB squared plus AC squared equal to BC squared. What I am going to do? I'm going to divide both sides by BC square. If I divide by both sides by BC square, we know this would be equal to 1. Here AB squared by BC square I can write like AB over BC whole thing squared. Similarly, if I divide AC squared by BC square, I can write AC divided by BC whole thing squared. Now AB is opposite, BC is hypotenuse. So what is opposite divided by hypotenuse? That is sin theta. AB over BC is sin theta whole thing squared. AC is adjacent, BC is hypotenuse. Therefore AC over BC is cos theta. So cos theta square, which is equal to 1. So we can, instead of writing brackets in trigonometry, we can write the sin theta square like sin square theta plus cos theta square. We can write like cos square theta, which is equivalent to 1. This concludes the proof.